Hello, we are going to solve problem 6.1. This can be found in uh, page 292 of the book. So let's get started. The first step is to have our data in standard order, which we already have, and we already have our table of signs that the book gave us. Now we have to make a sum, because if not, we cannot have Gates algorithm. So we do a sum, we run it. Now, for Gates algorithm, we must have as many columns as we have factors. So 3 columns. This is equal to this one plus this one, and this one plus this one, this one plus this one, this one plus this one, this minus this minus this minus this minus this. So now that we have the first one, we just have to take the other columns, and I am going to change the column of the color of this column to indicate that this is our contrasts. I'm gonna place it yellow, and this one I'm gonna place it green because this is our total sum. Now, the next step is to do an ANOVA. So, sum of squares, degrees of freedom, MSE, and Fisher. Yes. So we have A, B, A, B, C, A, C, B, C, A, B, C. Now, the formula for the sum of squares from the contrast is contrast squared over n, which in this case is 3 because we replicated the experiment 3 times. 3 times 2 to the k, which is also 3. Well, k is 3 because we have 3 factors. So that would be it. Now the error and total. Total would be calculated exactly as the other ones, as we have been doing the whole semester, which is the sum of squares of the data, these ones, minus the total sum squared over how many data, and we have 3 times 1, 2, 3, 4, 5, 6, 7, 8 data, so we have 24. The error is just this minus the sum of these ones, degrees of freedom. We have 1, 1, 1, 1, 1, 1, 1. Here we have 27 degrees of freedom, and here we have 20 degrees of freedom. MSE is equal to this over this. Run it for the whole thing, and Fisher is equal to this one over the error. We are gonna anchor the error so we can run the formula to all the other without it moving. There it is. Let me check. Yes. So now we are going to get our f values from the tables. This can be given from using a formula which is f inverse. Here we must have the probability, which is normally 0.05% is a good probability. 1 degree of freedom from this one, and 20 degrees of freedom from the error. Test that uses this. Good. Now I am going to color in red the ones that are bigger than the F tables, and that means that B, C, and AC are relevant factors for our experiment. All other factors do not interest us or well, have a small impact on our experiment. So now that we know that we just care about these values, we can just run a regression model with these ones. I have already done that because I don't have enough time. The book says that this can be calculated. 0 can be calculated as the average of all data. 2, the ones that appear in the factor, and minus the ones that do not appear in the interactions are the ones in the interaction as such, plus this one, plus 1, plus the one that does not appear in the interaction, minus the ones that appear in the interaction. So, and in each one you divide it by 4 times n. And that will not be all, because this is a big one. This will approximate this value, not each of these individual values. So we have to divide all of them by 3. So these ones are our true values. And if we run some example, we will see that it is correct.